Hi, in this module we will talk about data integrity. Data integrity is the assurance of the accuracy and consistency of data. The data that was created, or sent, remains the same when it is retrieved or received. It is a critical aspect during implementation and usage of any system which stores, processes, or retrieves data. What we generally want to achieve is to ensure that the information is free from modification and manipulation. The general technology associated with data integrity is hashing. Let's talk about hashing. Hashing is an one-way function. The important feature is, you will not be able to reverse the hashing process to reveal the original data. The ideal cryptographic hash function has the following main properties. It is deterministic, meaning that the same message always results in the same hash. It is quick to compute the hash value for any given message. It is infeasible to generate a message that yields a given hash value. It is infeasible to find two different messages with the same hash value. Finally, an arbitrary length input will produce a fixed length output. A small change to a message should change the hash value so extensively that the new hash value appears uncorrelated with the old hash value. Now, let's take a look at some of the more popular hash functions. Message Digest, or MD5, designed by Ron Rivest in 1991. Collisions against MD5 can be calculated within seconds in today's context, which makes the algorithm unsuitable for cryptographic hash use cases. MD5 produces a digest of 128 bits. It can still be used as a checksum to verify data integrity, but only against unintentional corruption. Secure Hash Algorithm, SHA-1. It was designed by the United States National Security Agency, and is a U.S. Federal Information Processing Standard, or FIPS. Since 2005, SHA-1 has not been considered secure, and disallowed to be used for digital signatures as of 2013. Replacing it with SHA-256. Let's use an online hash generator to illustrate this. You see, when I am keying in the inputs, the hash value keeps changing, and no matter the length I type, the hash value length remains the same. Take note that MD5, SHA-1, and SHA-256 generates different hash value length. Also, just by changing a single character, the hash value will be totally different. The applications of hashes are numerous. Examples are: 1. Verifying the integrity of messages in files. File or data identifier. Example: in GitHub, you can search for a source file by using the hashes of the file. The commit hash is a result of hashing information of the author, message, and the source code changes. 2. Signature generation and verification. Almost all digital signature schemes require a cryptographic hash to be calculated over the message. You can see that by double-clicking the lock icon on your web browser in front of any secure website URL. 3. Password verification. Password verification commonly relies on cryptographic hashes. Systems usually don't compare passwords as clear text, as this can result in a massive security breach if the password file is compromised. One way to reduce this danger is to only store the hash digest of each password. To authenticate a user, the password presented by the user is hashed and compared with the stored hash. A well-programmed software will also make sure the hashing function takes place as near to the input as possible. To ensure the password is not exposed as a clear text during transmission,